Hey, Anthony. Can you hear me? Anthony, can you hear me? Can you hear me? Oh, okay, good. All right, so I'm going to be walking around, so you won't see me here all the time. So, but I'll be mostly sharing my screen. Try to share my screen. Can you see my screen? Can you? Yeah, okay, excellent. All right. Welcome, everybody. My name is Jose Anunciato, and I believe we're here for CS3200, right? Database design. Okay, we're all in the right place. Yeah, so I'll be your instructor for the semester. So the intention is that we are all going to be here physically. Yay! I'm glad that we're all here together. I've been asked to make sure that we can at any point go remote if we're need to go back to lockdown to be ready at a moment's notice. So I am also recording all this material. On Zoom. You should be able to find all these lectures recorded for your convenience. Even though it is being recorded, the expectation is that still that you are going to be here physically. Right. But if you can't come for some reason, it's fine that you watch the material at some other time. There is time sensitive material, right? So make sure to consume that content as soon as possible, since there's going to be more or less one assignment every week. There's going to be quizzes and so on and so forth, and it moves pretty quick, the course. So definitely stay on top of that. Yeah, you should all have access to Canvas, and also I believe I've invited everybody to Piazza. Anybody not receive an invite? If you haven't, please see me after class. I'll make sure that you do get an invite. That's going to be our main mechanism for interacting. If you have questions, you should definitely first go to Piazza. Most likely someone else already asked that question. See what answers they've gotten. We do have about 5 TAs that are going to be helping out, and they're going to be watching for questions 24/7 almost, throughout the week and weekend. If you do ask, we try to have a short turnaround. Yeah, so the TAs are going to help us a lot on those questions. If you do have a question about the course or the TA maybe took off a point where you don't think that he should have, then certainly those kinds I can resolve some of those. Okay. Um, Piazza allows you to have private messages. So you could, if you do want to send me something specific to me, you can still use Piazza, right? But you send it as a private message if you need to. So there's no need to send separate emails or anything like that. Let's try to keep it all communication through Piazza. It's easier for us to just have it all in one place. Okay. Let's see. So Zoom lectures are again are available there, and if you go to the dashboard in Zoom, you should see any past recordings. So you should be able to see within a few minutes after the end of class. Um, uh, let's see. I'm also gonna upload these the videos to YouTube. Some students prefer to consume this content on YouTube as opposed to Zoom, right? So I'll make it available. I'll create a playlist where you can watch that as well. I will make available any source code that we work here in class. My courses tend to be a lot of hands-on, where we do a lot of coding here in class, and I show you some examples. And first you watch me do it, then we watch you do it, right? It says having seen me, you try to do it yourself again, and then towards the end of the course, the intention is that together with some of your team members forming a group, a team, you will work on a project of your own, right? You'll come up with some idea, and having learned what would be learning throughout the semester, you'll build something on your own. Well, not your own, with 2 or 3 other folks collaborating. So yeah, so the project is final project is collaborating with 2 or 3 other folks, whereas the assignments are all individual assignments, right? So you're intended to do it all on your own. You're welcome to use any source code that I provide, right? For your own purposes. You can repurpose it. You can just use it verbatim. You don't need to change anything, and you can just add to it to need to complete. Please abstain from looking at anybody else's code. It's okay if you discuss the problem or how somebody else might have approached it and what challenges they might have had. That's totally fine. But please abstain from looking at anybody else's code and obviously copying anything. If you do find something online, again, I mean, sure, read about it, but don't verbatim copy anything. And if you do, sometimes something that doesn't pertain directly to the assignment, if you do copy something, not necessarily something that I've asked you directly to do, then that's fine. Just make sure that you label it, that you give credit where you got it from. Maybe it's a function that sorts lists or something, whatever, right? That's fine. If there's plenty of source code out there that does all sorts of things that we don't have to reinvent, that's okay. Make sure that you give credit from where you got it from and how it doesn't pertain to what we asked you to do. So let's see. Yeah, so these are some of the resources. Office hours. So office hours for me is going to be right after class. So we've been asked to have all our office hours remote, right? So I'm gonna be here in the university, but I'll have my office hours from my office. Okay, so I'll just not 15 minutes after class to get to my office, and then I'll start the office hour. Not today. I have to pick up my son from practice. But yeah, but typically it'll run from 3:30 for an hour or so, and so on Tuesdays and Fridays, right? So we're meeting here Tuesdays and Fridays after class, office hours at 3:30. The TAs are also going to be holding office hours twice, 2 hours twice a week, right? They're spreading out the office hours throughout the week, trying to have some coverage everywhere except no week. Oh yeah, we do have a weekend. But yeah, so make sure that definitely use those resources. You'll have a TA that is assigned to you, but you can go to any TA if you have a question about the assignment or anything like that, or you need help. Or not, you can go to any TA, right? But there will be, TAs will take a group of 15, 20 students, which they will be responsible for grading. But if you do have any technical questions, you can go to any one of them. Yeah, some of them are using Zoom, some of them are using Team, right? So make sure that they use the right communication tool for collaborating. All right. Let's see. Any questions in the chat? No? Okay. Yeah, I do have, I believe, 2 students that are online today. Let's see. Okay, so let's take a look at the syllabus. Right. So the goal of this course is to learn how to design databases, right? And we don't mean design the software that implements databases, right? We'll assume that there is a database, and then we'll use a database to a database system, right, to implement a database, right? It's kind of redundant, right? It's usually it's overloaded term, but basically we're going to learn how to create data structures, right, using SQL, right, SQL, and you know um, we'll define different objects that are related to one another somehow, and each one of these objects will have all sorts of properties, right? You know, there will be employees and students and courses and all sorts of nouns, right, that we want to describe, right? And each one of those nouns will have all sorts of properties, right? And they'll have colors and age and date of birth and first name, last name, all the properties that describe each one of these nouns. So we'll learn how to describe this using structured query language (SQL) into forms of tables. Right, each noun will be described as in a different table, and each record, each row in these tables will represent, you know, a particular instance of a student, or a typical instance of a course, or a typical instance of a university and whatnot, right? And so we'll learn how to design that. There's a lot of decisions that go into deciding which tables to use, what to call them, what are the properties, what are the data types. You know, should I use an integer, a float? Is it a string? What is it? Is it a date? How do I represent all the data? And then so there's a lot of decisions that go into that, and also the structure. You know, how is each object related to other objects, right? A course has many students, right? A students is related to lots of quizzes that they've taken, right? All these assignments have been taken by all these students. What are the grades for all these assignments, right? So all these nouns and verbs that folks use to describe the real world, right? And that needs to be described mathematically, you know, formally, needs to be into a program, into a language, right? A formal language that describes this data in bits and bytes. Okay, so there's a process that goes from, you know, somebody telling me something, describing something in plain English, right? And how do we transform that plain English into something that is structured, right? That is consistent, right? And meets some of the requirements, right? For instance, we don't want redundancy. Okay, you know, if you have a piece of information, you want it to be stored once, not multiple times. You know, we say that redundancy breeds inconsistency, right? So we want to eliminate inconsistency, right? You know, the example I always use, if you have, especially if two things are supposed to be logically the same, right? It would be inconsistent for them not to be the same, right? So if I have two watches, right, and logically the two watches should give me the same time, right? And it shouldn't matter which one I look at, right? But because of whatever reason, for any different events, it might be that one starts to go ahead of the other. Okay, and now two things that should have been the same, now they're not, and so now that kind of diminishes the value of both watches. Which one do I trust? Do I trust one or the other, right? Because of inconsistency, because it was redundant, because I had two places to see and watch, right? Now this inconsistency devalues, right, the actual data, right? And our responsibility as information technologists is to guard this, right? Guard from happening, right? We want to, the information that we are capturing is structured in such a way that is consistent, that anytime you ask the same question, you always get the same answer, right? Or that not that if you ask it one way or you ask it some other way, that there's logically the same, you get two different answers. That would not be consistent, right? So we need to guard against that. So yeah, so that's the course is about designing databases that meet this criteria. Also criteria of that it has to be accessible by not just one person, but by thousands of people, right? That are simultaneously using your database, right? That are sending queries and updating the data and deleting data and inserting new data, right? Well, how do you make sure that people are not, you know, stepping on each other's toes? Right, that imagine you have this huge document and I'm writing on this paragraph and you're writing over there, as long as we stay far away, perhaps we don't override over each other. But what happens if we're close by, right? Imagine a Google document, right? And you're writing on this paragraph, and I'm down here. That's okay. But as we get closer, hey, you overwrote my paragraph. You deleted something that I wrote, right? So we want to make sure that yes, we want multi. Hello, can you hear me again? I don't know what went off. Must be a timeout. Yeah. Yeah, so that's the focus of this course. How do you design databases to meet certain criteria? So assignments, there's going to be about 10 assignments, perhaps one every week, except halfway through the semester we're going to have an exam, and towards the end of the semester we're going to have another exam plus a time for dealing with the working on the project, right? So, but there's going to be 10 weeks, so you can assume that there's going to be an assignment every week. And there's a team project at the end. We the teams can be between one person and four in the team. I think one person per team. I think that's a little bit too much work for one person. But if you want to go along, that's totally fine. Also, 4 people working on the team, I think that's too much. Unless you're really good friends and know about each other's work ethics and whatnot. If you can rely, that you can rely on your teammate, then perhaps a 4-team group is fine. But if you're working with someone who you don't know, not sure, I would avoid large teams, right? At the end of the semester, I always get complaints on, oh, I worked more than they did, and I'm worried about my grade. They didn't do anything. I had to do a whole bunch of all-nighters trying to do what he was supposed to do, and let's try to avoid that drama towards the end of the semester, right? So only work on large groups if you are confident that you can deal with these kinds of issues, right? I think ideally it would be like a 2 or 3 person team. That would be ideal, but 1 or 4, that's fine as well. Yeah, meetings, again, the expectation is that you are physically here, but nonetheless we are ready if we need to go off remote, that's fine. The lectures are available here. My office hours, that's my personal Zoom, right? So just join there. We are using Piazza, and I believe folks have already started asking questions. Yes. You mean other sections that are doing 3200? I mean, I'd be fine with that. We'll need to coordinate with the other instructor. How is it going to be graded? Who's going to be grading what? And so yeah, we can consider it. Yeah. Yes. I'm sorry. The when by when you're going to choose it? Yeah, I'll let everybody know when there'll be a message. I would start right away. Right. Also, I would start away on coming up with an idea of what it is that you might want to build. Um, especially if you're thinking of something. So I do have a set of requirements that we're going to be going through. That everybody has to meet these requirements. And I think most 80-90% of the teams will fit within this box that defines the requirements. But if you want to go beyond that and go do something outside of the box, we can certainly negotiate on how that would be graded, because I already have rubrics for my standard requirement set. But if you explore something else, definitely. So if you do want to go outside of the box, I would definitely start right away of looking at what is it that I want to do. And if you have an idea in mind, I would get on it right away. Other than that, we're going to be going over the requirements soon. Yeah. All right, so here we are. That's these are our office hours, Tuesdays and Fridays, right after class. My Zoom. The TAs are going to be updating their information here when they're going to be holding office hours and providing links to their Zoom or their team. All right, so here's the agenda. So today is going to be just obviously just introduction to the course, and we're going to get started on installing a database, right? So in this course, we're going to be using MySQL, right? It's a fairly simple database, fairly well known. It's widely used in industry, so we'll be using that. I mean, there's tons of other databases we could have chose, right? Oracle, SQL Server, Postgres. There's tons of them out there. We're going to be using MySQL, but most of what we're going to be learning about MySQL is readily transferable and usable in any other database that you might be using. Towards the end of the semester, we're also going to be playing around with Mongo, a non-relational database, right? Most of the course is focused on relational databases, right? But more and more in the industry, we're seeing a lot of non-relational databases that are being used, such as MongoDB, that are becoming more and more popular. But yeah, no, most of the course is relational. We'll learn how to install it. We'll create a schema. We'll create a couple of tables, and we'll insert some data and interact with it. And next week we'll start earnestly talking about designing a database, right? And the designing of the database typically starts from a some description of what some requirements, right? There's we gather the requirements from folks that are not software engineers, right? They're either a business owner or somebody in marketing or on engineering, right? We interview them, right? And we write down in plain English what is that they describe us, right? And our job is to transform that English that English description into something formal, right? Some very informal description in English that is very inconsistent. English is very inconsistent, right? You can interpret different things. Different words might have the same meaning, right? And so how do you convert something that is vague, right? That is contradictory, it's inconsistent. How do you convert that into something that is formal, right? And that meets the requirements. So we're going to be using UML. UML is a widely used graphical language, right? That's just boxes and lines that will allow us to design it, just graphically and describe each noun and each verb, right, with boxes and lines, and see what the relationships are of the different pieces of information that we want to capture. All right, so we'll do that. No coding, just boxes and lines. Then in the third week, we'll talk about how do I convert. So we'll go from a descriptive English version, right, of the requirement. We'll go to a graphical representation, a formal representation, right, where we've removed all the inconsistency. We've removed all the vagueness, right, and described it in UML. And then we'll say, well, how do I then code it? How do I actually insert into my database and create the tables and whatnot, right? So we'll spend a week doing that, how to create tables and implement different functional dependencies, normal forms, make sure that we remove dependencies using normal forms. And then we'll start talking about, well, how do I insert data, right? Once I have data, how do I retrieve that data? How do I insert the data? How do I retrieve data? How do I update data, delete data? How do I manipulate that data? So we'll spend a couple of weeks doing that, querying the database and updating the database. Then, and all of this up to this point, it'll be SQL, right? So it'll be about 3-4 weeks of SQL, right? Then we'll see that SQL has some limitations, right? That it's mostly declarative, right? It says, give me the countries that have a certain GDP between the years, blah, 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 right? So you declare what the information you want, right? And the database just goes on and it retrieves all that data, yes? But it's declarative, okay? And in declarative, languages have limitations. So we'll talk about using plain old programming languages, right? Where now it's functional. You can functionally describe an algorithm, right, that can interact with the data, right, where it can iterate over rows, right, and retrieve different pieces of the rows and do calculations over it, right? And it can programmatically interact with the database, right? You can either program it right within the database, right, with its own language, or you can use external languages like Java or Python or any other language outside just normal programming languages that can interact with the database, right? So we'll explore those two ways of interacting with database programming. Okay. Week 7, we're gonna first have a review on Tuesday, right? I'll give you a sample exam from past semester. Hello? Okay. At the 7th week, we're gonna have the exam. All right, so when we come back, we'll start thinking about advanced ways that we can interact with the database. Okay, up to this point, we're going to be interacting with at a very low level, right? SQL now it's going to become very low level, right? Almost like assembly, right? You don't want to have to program with such a low level programming language, right? We have created other abstractions on top of assembly language, right? More powerful languages that are much more descriptive, right? That allows us to create even more powerful applications, more complex applications, right? And that's why we invented, things such as object-oriented programming languages, right? And we invented component, and we invented all these other design patterns, right? Singletons, right? And data access objects and facades and whatnot. So there's a whole bunch of design patterns. Anybody did a software engineering here yet? Anybody? No? Okay. There's a whole bunch of design patterns, right, that folks in the industry have been applying best practices over many years, right? And they've discovered that certain things work and certain things don't work, right? And somebody has been writing down all the things that work, right, and all the things that don't work, and then we call them those design patterns. Yes, and so that engineers that that come later don't have to reinvent the wheel. Okay, when they're faced with a new problem, they can see, oh, what have other engineers have done in the past, right? And they can look. There's a whole bunch of libraries books that describe all the good things that you should do, and we call them design patterns. Yes. Well, one of the design patterns is the object relational mapping design pattern, right? Where you have a SQL, right? Tables that are usually implemented. They're very flat, right? You have tables, and then tables can refer to each other. They can point to each other, right? A record can reference another record, right? And usually we think of that as a flat model, right? There's no way to create hierarchies. Okay, there's no way to group things, right? There's no easy way anyway to group things that go together, other than being in the same record, in the same table, obviously, right? But object orientation, just gives us a much more richer way of thinking about data, right? And we have things such as inheritance, right, where objects can be described at a very high level, right, and then you can have more specific versions of those objects, right, organized into a hierarchy. Yes, right, and the reason we've done that is because we want to be able to tackle much more complex problems, right? That's why we want to be able to think about problems in different layers of abstraction. Okay, but databases don't support that, right? Databases are flat. You don't have those kinds of hierarchies. We have the idea of objects, and we have the idea of methods and of sending messages amongst each other, right? And overriding and overloading, things like that, right? In object orientation, we don't have any of that in SQL. So ORMs, or object relational mapping, is a technique or is a design pattern that attempts to map the flat world of SQL, right, to the object-oriented world of object-oriented programming languages. Yes? Okay. So that a row in a table can become an instance of an object in memory. Okay. And it's not trivial to do this, right? It's not very easy because there's so many things that are not supported in SQL that don't have a representation. There's no such thing as inheritance. How do you do inheritance in SQL if it's just not supported? How do you map it into a inheritance hierarchy, right? So object orientations will allow us to do this mapping between these two worlds. Make sense? Very, very cool. Then we'll spend about a week on database driven web applications, where this is just one of a plethora of applications on using databases that are then drive some application, right? A database is only part of a much larger system, right? That is the application, right? The database is only responsible for storing the data and retrieving the data, right? And making sure that this data structure is consistent, non-redundant, blah, 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 yes, right? But it's only a part of a much larger application, okay? And that application could be a desktop application, right? It could be a mobile application. It could be all sorts of things, yes? We're gonna be spending a week discussing a specific use of databases, and it'll be web applications, right? I could have chosen desktop, I could have chosen mobile. Web, I think it's the easiest way to just describe what an application would look like that uses a database, right? So we'll spend some time. I'm going to be using React.js to interact with a database, right? So we'll be able to have some kind of user interface, right? Again, this user interface we could have used anything to create this user interface, right? I chose a web client, so we'll spend some time there. This one's going to have a lot of hand holding. Okay. I believe I almost do the whole thing for you, right? So you just have to follow along the steps, right? And I mostly do everything. Just make sure that you practice it, you understand it, so that you can then perhaps use it in your own projects. Okay. All right. So then we'll spend a week about optimizing databases, right? So what are the challenges as the database gets bigger, right? What challenges do we have on the performance of the database, right? If I do a query, the intent is that my expectation is that it comes back with the answers right away. I mean, Google, you make any dumb query and it comes back with a half a millisecond, right? I mean, it's oh, I just checked 3 billion pages, right? And half a millisecond says, okay, well, I'm expecting that kind of response, yes? So we'll talk about the things that affect performance, okay? Why a database would perform poorly, and what can we do to improve its performance. We'll also talk about transactions on when you have tons of folks, right? Dozens, hundreds, thousands of folks, interacting with the same database. What could go wrong, right? How do I avoid people stepping on each other's toes? How do I make sure that nobody's overriding anybody else's work, right? So transactions are going to allow us to deal with that. Well, then we'll spend a week on non-relational databases or non-SQL databases. Like the name says, right? It's no SQL. We're now going to use SQL. Each implementation, Firebase or Mongo or any of these databases, they all have their own libraries and their own language on how to interact. It's just non-SQL. All right. We'll talk about Mongo and we'll talk about Firebase. Then we'll get started in earnest with the project. Hopefully by this time you've already started. You have an idea of what it is that you want to do. Perhaps you even have a prototype of what it is that you want to build. Okay. Ideally, once we've hit the web-driven applications, you should have enough knowledge to start building your own things. All right. I think one of the things that I suggest is that you take what I give you right here, right, and start tweaking it for your own purposes. Okay. This is not a web class, right? So we're not gonna be evaluating whether right, it's pretty, or right, if things are justified, or you use the color, the correct color palette or whatnot, right? We're looking for something that is functional, right? Can you insert? Can you delete? Can you update? Right? Can you retrieve data? Right? Can you connect to a database? Right? Things like that, right? That's what we're going to be evaluating, and the front end is just a means to an end. Okay. Yeah. Then we'll break for Thanksgiving, and when we come back is just mostly project. Again, ideally you would be working on your project, at least 1 or 2 weeks before week 12, and ideally on week 12 you would hit the ground running on building something, on actually implementing something. But there's about 3 weeks here that are dedicated to completing the project. When we come back after Thanksgiving, we'll talk about the project some more. We'll then on week number 14, we'll do exam review. We'll do the final exam. Any questions? Yes. Sorry. No presentation. Well, to the TAs, right? You'll meet with the TAs, right? And so for these three, you'll meet with the TAs. The TAs will give you some feedback, right? Whether how you're doing, and you'll correct course, and this would be your last presentation, right? So this week would be a week of presentation, where you meet with them for 20 minutes to an hour, and they'll give you a grade right there. Okay. Well, we have a week for us to find to complete any grading, or if anything's missing, and then the grades. I have to have grades due on the 20th, and then the 21st. The grade should be on my NEU. All right. All right. Let's see. The assignments are 40%. Quizzes are 10%. Projects 30%, and the exam, each one is 10% each. Makeup policy. So I don't have a makeup policy. Is the assignments are due whenever they're due. If you need more time, but basically the policy is that you lose 1 point for every hour that you're late, right? So if you're 5 hours late of submitting it, then your maximum grade is 95. Okay. So there's no need to ask me, right? We'll just automatically see whenever you submitted it. If it's late, it'll automatically be deducted that many points. Okay. The all the assignments are submitted on Blackboard or Canvas. Academic integrity. Please make sure that all your work is your own. Right, the TAs are very good at identifying patterns, on looking at lots of code from you that's coming back, and and they'll be looking for things that are similar. Obviously, if it's something that I gave you, code that I gave you, then obviously that doesn't count, right? But anything that we've asked you to do, make sure that it is yours. Especially towards the end of the semester, spare me the drama of having to report you or go to Oscar. It's very uncomfortable for you, for me. Please don't put me in that position. Okay. I mean, it's yes. No textbook. I will provide things for you to read before class. Yep. Yeah. All right. Okay. Let's see. Let's move on. All right. I'm gonna get started with the first assignment. Get you going. The slides here, the downloading, installing, and connecting, are basically walking you through completing that first assignment. Okay. And if you open it up, what it's going to ask you to do is to download the database that we are going to be using, right? MySQL. If you click on that link, it takes you to a page that looks like this, right? And you can download it for Microsoft or Mac OS or whatever you have. And if it's a Windows, it'll download a MSI, or if it's a Mac, it'll download a DMG, right? And you double click it, and it goes through its installation, right? It's slightly different for Windows and for Mac. For Windows, you can choose to download two things that we need, right? We'll need the server, and we'll need the client, Workbench. Okay, I'll go through the slides, but basically we need two pieces of software. On a Mac, it's two separate things that you have to download them independently. Okay, so it's slightly different if it's a Mac or Windows. If you click on it and you start downloading it and installing it, it'll look something like this, right? So here it is. Where are you going to use the community server, right? That's the free version of MySQL. It has a couple of restrictions or what things you can do, but that's fine. It's plenty for what we need here in class, right? So we'll need these two pieces of software, right? This is a server, right? And this is the client, right? The server doesn't have a UI. When you run it, it kind of runs in the background, okay? And it's responsible for actually storing the data in a file system and retrieving data from the file system, right? And basically you connect to it through a network, right? And then you send messages to it, okay? And the messages is, hey, here's some information, insert this information, now retrieve that information. And so you send SQL commands back and forth, right? And you get back data from the server, right? And so we need a UI to be able to interact with the server, and that's what the Workbench is, right? The Workbench is just a UI that allows you the convenience, right, of typing information, the commands, sending those commands to the server for execution, and then graphically representing the response in a nice little table. Okay. There's many different other clients. You don't. I'm going to use Workbench, but there's tons others out there, right, that you could use. That could be clients to the same server, right? But those are the ones that we're going to be covering in class. Basically the architecture looks something like this, right? So here's you, right? You're using this user interface, this Workbench client that is sending SQL commands back and forth, right? And then the MySQL server is running in the background and then stores the data in some files, right? And then it retrieves those files and sends them back to the client for you to view, right? So on Windows, right? If you download it, there it is, the MSI. You download it. It's going to ask you if you want to create an account, right? You don't need to create an account. You could just skip over that. Just say no thanks. Just take me to the download. Can I present this? Let's see. When it asks you the setup type, you can choose custom, and then it allows you to then specifically choose what it is that you want to install, right? And if you tell it to install everything, it's just going to install tons of stuff that we're not going to use, right? We only need those two pieces of software, right? The server and the client, right? So if you do custom, then you can choose that you want the server and that you want the client, Workbench, right? So you can choose both the server and the Workbench, and then say next, and it'll start installing it, right? It'll start executing and downloading and installing it. We can choose that it's a standalone MySQL server. You can set up, I think this is the default, the development computer, TCP/IP 3306 is the port the server is going to be listening. That's a classical standard port that MySQL uses, right? Don't change it, right? So since the user interface assumes that it's 3306, right? If you change it, then you're going to have to change it also on the client, right? Yes. Yeah, the latest one. Yeah, the latest one's fine. Yeah. Say that you want to use a strong password encryption. And here, this is the root password, right? This is the root password. Don't forget this password, right? You can write something really, really simple. This is a password just for yourself, right? And on a piece of software that is running on your laptop. So it's not like somebody's going to come in and try to log in into your database and wreck your database, right? So you can use just a simple password, something that you could easily remember, right? If you forget it, you're going to have to go through the whole thing again, right? And reinstall everything. So don't forget this password, right? This is the root password, okay? And then when it's done, you tell it to to run the server every time the machine boots up, right? So that it'll always be running in the background, right? I suggest that you run it like this for at least for this semester. At the end of the semester, you can then turn it off and say, okay, well, don't start it up every time I start up my machine, right? But it's convenient just to have it running in the background, at least for this semester. Once you get to December, you can say, okay, stop. I don't want you to boot up again, right? Okay, for macOS, it's just slightly different. You download it for macOS, no thanks. And yeah, when you download it, it becomes a DNG, and it's you unzip. Because it's a piece of software that was not downloaded from the App Store, right? You're gonna get a security message saying, "Oh, I can't run this because it wasn't from the App Store," right? You're gonna say okay anyway, but you'll have to remember that to go into your system preferences, into your security and privacy, right? And once you are in there, it's gonna it's going to tell you that it was not able to run the installer, right? And you're gonna have to give permissions. It says, okay, open anyway. It says, yes, I know I didn't download it from the App Store, right? That's okay. I want to run it anyway. So it's gonna install it. Install for all users in this computer. It's gonna ask if you have a password on your laptop. It'll ask you for that password. Just give it your laptop password. So giving it permission to install. It goes in and copies to your hard drive. Use strong password just like we did for Windows. This is the root password again, right? But for Mac, again, don't forget this password, right? If you forget this password, actually you can reset it in the preferences, but it's very inconvenient, right? So don't forget this password, right? Again, it's only for software that's running on your machine. It's not super important, but again, don't forget it. And then it's done. All right. So once you're gonna have your SQL is running on Mac, it'll show up on your system preferences as a new icon, right? And on Windows, it'll show up on your services. If you go to your services, you search for MySQL, it'll be an entry there, right? And that's where you can choose to automatically restart, right? Or shut it off, right? So it doesn't restart on reboot, right? So on Mac is here on the MySQL. And just like on Windows, right? You can in the services, right? You can stop and start the server from this preferences. Okay, and here's where you can check whether the server is running. All right, so yeah, you should have now your server up and running. Okay, so that's what the first part of the assignment asks you to do, right? Installing MySQL Server for Windows, and then down below, installing it for Mac OS. Okay, right? Do that. Just gives you the steps on how to do this. Then the next part is that once the database is up and running, we want to have Workbench and the server talking to each other. Yes. I'm sorry. No, not as an application, right? It'll be running as a background service. So if you look for services, right, it'll be listed there. And there's a search bar where you can search for MySQL, and it'll be a line there where you can start and stop it and configure it to restart or not. Yep. All right, so the next part is that now we want the client and the server to talk to one another, right? The UI and the server, okay? And so to do that, you you have the server up and running, right? And you start now the Workbench. We start Workbench, and we start Workbench, right? It shows that you can create connections. So let's see. Let's start Workbench. So here's Workbench, and so this allows you to create any number of connections, right? Could be to the same database server that is running on your machine, or it could be a connection to a server that is running halfway across the world, right? As long as you know the IP address of where your server is running, you can connect to any database, right? Running anywhere in the world, okay, right? For in this class, most cases where we're going to be just using localhost, right? Localhost is referring to the machine that you are working on right now, right? Also, localhost is also an alias for the IP address 127.0.0.1, right? Which is also referring to the local machine that you have in front of you, right? If instead, if it's this is a server that is running on AWS, or it's running somewhere in Eastern Europe or whatever, right, halfway across the world, right, you'll need to know their machine name, right, or their IP address, yes, right, and the port where they're listening at. Usually that port is always going to be 3305, but it could be something else, right? Whoever is providing for the service, whoever you're paying to provide for the remote server, right, will let you know what is the full IP address or name of the machine that you can connect to. Yes. For this class, we're just going to be using localhost, right? The server is going to your database server is just going to be running on your local machine. Okay. This one is using root for username and password logs into the server, and this one, instead of it's using a bogus name, your username and your password to log in to the same server. And so I forgot my root password. It's been a whole summer. I don't remember my root password, so I'm just going to use this this other user. But it's the same database. It's the same database server. You can have any number of users, right, that you can define for the same server. Okay, there we go. So we are up and running in Workbench. It's going to be a little bit different. The UI is slightly different from between Windows and Mac OS. Windows tends to put the tabs at the bottom, whereas Mac tends to put the tabs at the top. Okay, but other than these minor differences, right? They're basically the same thing, right? The buttons look different. It might look a little prettier on a Mac, perhaps, right? But other than that, it's the same piece of software, right? I believe on a Mac, these two tabs are at the top, and these two tabs are up here, something like that. But other than that, it's more or less the same thing. Okay. So yeah, so there's Workbench. It's connected to the database server that is running in the background, right? Right now, I don't have any schemas. Schemas are like its own database, right? Its own collection of data sets, right? Of collection of tables, right? And usually a database will be for a particular project, right? So you can divide, maybe have a schema for your project, another schema for the assignment, right? And so each project will have its own schema, right? And then a schema will have the set of tables, and then each table will have a set of rows, right? Or records. Okay. So first we'll learn about creating schemas, then we'll create tables, and then we'll create rows inside of those tables. Okay. All right. So we're connected to the database. This asks you to create a brand new connection. I don't remember my users, so let me just look at my users that I have. Okay, I have this username. I believe the password I chose was your password, your username, your password. I was using that because for the assignment, I have in the instructions, use your username, use your password, and students were literally using your username and your password as opposed to using so I started using it as well, so just to make sure that everything worked. anyway, so yeah, so I can create other users, add account. So I can say a new user wants a CS3200 for my login name and my password. I'll use the same password, so CS3200. CS3200. Apply. I'll make this user a super user. I'll make him a DBA, a database administrator, meaning this person's going to have godlike powers. They can do everything. There's nothing that they can't do with the database. What else? Schemas. They can modify anything they want. They can alter, delete, drop, insert, everything. So I'm going to apply that. Okay, we have a brand new user, CS3200. If I go back and close my connection, notice this tab. These tabs is tabs of different connections that with different databases that you might be connected to. Right? If I'm going to close that, I can now go back and create a brand new connection with my brand new username that I just created. Right? And I'll call the connection the CS3200 fall 2021. It's running on this machine, so it's 127.0.0.1. But if this was running somewhere in Italy, then somebody would have given me the IP address of that machine running in Tuscany or something, whatever, right? They give me the IP address. I would type it here, right? And now I would be connected to a database that is running halfway across the world. Instead, I'm going to be connecting to a database that is running right in front of me. Yes, because it's 127.0.0.1.36. So I'm not going to use root because I don't remember my root password. Instead, I'm going to use CS3200. And it's going to ask me for the password test connection. It'll ask me for the password, which I believe it was 3200 again. I'll save it. It was successful. I'm going to say OK. And now I have my brand new connection. Right? If I click on it, it basically puts me exactly where I was before. Right? It's two different users connecting to the same database. Right? And right now it's on my same machine, but it could have been, my son, my daughter, somebody else, right? All connecting to the same server, each one running their own workbenches connected to the same machine. Make sense? The same server. Okay. Actually, I do have in one of the assignments, I do ask you to have two different instances, two different connections, right? And log in as different users, right? And then try to override each other's work, right? You insert something and then somebody else tries to delete it at the same time, right? And see what happens, right? How do I handle concurrency, right? When you have people that are writing stuff and people are trying to update or delete stuff at the same time, you want databases to be able to support that, right? Same, and this happens all the time, right? If you go to kayak or you go any airline, right? Or you're trying to rent book a flight or book an apartment or a car, right? And it tells you these are the seats that are available, right? But you're not the only one looking at this, right? There's hundreds, thousands of folks looking at the same piece of information, right? And how do we know what I'm looking at is stale? That I click on a seat, but that seat is already taken by someone else, right? We're kind of competing for that same seat. Well, databases need to be able to support that, right? Of having hundreds, thousands of people looking at the same piece of information, interacting with simultaneously. Okay, let's see. So once we have that, we're going to create our very first schema. Again, a schema is just a collection of tables, right? And typically we create a brand new schema for a brand new project, right? I'm going to create a schema here that we're going to be using throughout the semester. I'm going to use a generic name. I'm going to call it, DB design, right? But we're going to be building tables that deal with a university, right? Where things that describe a university are things such as students, courses, sections, right? Assignments. Those are typical nouns that you use to describe things about a university. Yes. So we'll have tables that describe each one of these nouns, right? But if this were some other industry, then it would be a different database with its own set of tables that describe other things. Make sense? Right? So I'm going to use a generic name, but perhaps a better name might be university, right? That'd be a better name for my schema, right? It's a more descriptive. Okay. Actually, let me do that. So I'm going to create a brand new schema. You can say you can either right click on the left hand side, clicking on the schema tab. Once you're in the schema tab, you can say new, create a schema here, or you can use this icon here to create a brand new schema. So this brings you to the new schema screen, where you can give it the name of the schema. And actually, no, let me use DB design, because then everybody's going to get confused. Everywhere in the assignment, I call it DB design. And then everybody, I'm going to just use DB design. Okay, and then apply. So again, this is just a UI, right? The UI doesn't really do anything. It just takes the what you enter in the forms, and then it formats the command that is going to send to the server, right? And then the server executes the SQL, right? And magic happens. So notice that it wrote for me, create schema, DB design. I could have actually just typed that myself, right? And then send it myself, right? The UI is just a convenient way, right, of writing SQL for you, right? But there's no, I mean, MySQL comes with a command line interface, right? But there is no UI, right? It's everything at the command. You type everything, every single line of code, right? So it's very inconvenient. It takes forever to write all these things. So that's why we're using the UI, so they write it for us. Okay, we're gonna say apply, and it says, very good, it's done. And there it is. There's my database. Okay. Now I could have many databases, right? I could have a database that deals with space, right? And then I could have maybe another one that deals with cars. Okay, finish. So at the end, I could have many schemas, and each one can have its own set of tables that describe things, all things space, all things cars. Yes. Now, if there's a particular database that you're using over and over as a convenience, you can double click that database, and notice that it becomes dark, bold. See that? Now that database is the default database. It's called the default database. That means that every command that you type now is going to be within the context of that database. Yes? All right. If you don't have it selected as a default, all the commands you would need to specify exactly which schema are you talking about. All right. Okay. So as a convenient, it's a good idea to double click on the database that we're going to be working throughout, right? So that it's the one that all the commands are going to be directed to. Yes. It's an overloaded term, right? So here, folks might refer to these as 4 databases, right? But the correct term would be a schema, right? It's a collection of tables, right? Of a schema. The actual definition of a schema is a data structure, right? It's a large data structure that describes many nouns and the verbs that are related to one another, right? And what the structure looks like, whether it's hierarchical, and what are the references that I have each other, right? Which is exactly what it is, right? A database is a little more high level. It would be referred to maybe the database system that allows you to interact with that schema, right? But inserting and deleting and removing and modifying that schema, right? So a database is a little more broader, but oftentimes folks use that interchangeably, and they'll refer to the schema as a database, right? But we understand what we really mean, right? This is a schema. Yeah. The whole piece of software folks also refer to as the database, right? Well, no, there's a client and there's a server, right? And together, oftentimes folks refer to as a database system, right? Together, the client and the database, right, as a database management system, a system that allows you to manage databases. Yeah, I know databases. The term is used for all sorts of things. But yeah, no, we're going to be using schema for referring to these on the left-hand side. All right, so yeah, we're going to be using the DB design. Notice that when I open the DB design, it says that I could have tables in there. I could have views, store procedures, functions. Okay, we're going to be focusing the first, I don't know, 4 or 5 weeks on playing around with tables, right? We'll play around, we'll create tables, and we'll learn how to create tables, how to insert into tables, remove tables, update tables, delete tables, how to create tables that are related to one another, one-to-many, meta-to-many, mapping tables, all sorts of things like that, primary keys and whatnot. We'll spend quite a bit of time there. We're going to spend some time in views. Views are convenient ways to look at tables. Okay, one of the things that we're going to be drilling into you for the next couple of months is redundancy breeds inconsistency, right? And we're going to be looking at ways, techniques. How do I avoid redundancy? All right, and we're going to talk about normalization and how is it that you break up large data sets into smaller sets. Like I said, one of the main questions is you might ask, why don't we just use one table for everything, right? And especially if you've used Excel or a spreadsheet, yes, where you have tons of rows and tons of columns, and you start just writing different pieces of information, right? Maybe maybe from a poll that you've made, right? Or and that what people are answering to different questions, and you have different columns and different rows, and you say, well, I mean, one spreadsheet is plenty, and then you start looking for your code through your data, and you start finding a lot of redundancy, right? For instance, you ask a family, you ask it the same question, and they might answer different to different questions, but they'll answer the same about their address. For instance, they all live in the same house, right? So one of the questions is, wait a minute, am I going to write? I've asked people, they live in the same household. I'm going to enter 5 times the same address, right? So that should, from a database point of view, that immediately a flag should come up and says, wait a minute, no, you're committing redundancy. That's that's a sin, right? You can't do that. It's blasphemy. You should not find yourself ever entering information more than once, right? So right there, no, using one spreadsheet is not the correct way of doing it, right? Instead, you would have perhaps a different spreadsheet where you have the address entered only once, right? And then those original 5 rows would refer, if you want to know the address of these 5 people, well, refer to this one single row elsewhere in a different spreadsheet. Right there we have applied one of the principal ways of eliminating redundancy, which is called normalization. Normalizing a database is the process by which you break up large pieces of information that might contain redundancy into smaller pieces, right, into multiple tables to remove the redundancy. Yes, right. And again, redundancy breeds inconsistency. What if you misspell one of the addresses, right? And one is Adam Street and the other one is Adams Street, and it's misspelled. Are they now in 2 different addresses? No, right? Logically, they're supposed to be the same address, right? And if you start querying and you're counting, well, how many people are in this household? And depending on how you ask it, it says, well, there's 4 people in the household. Well, no, wait a minute, there were 5. What's going on? Oh, it's because I misspelled it, right? Redundancy breeds inconsistency, right? So a lot of things that we're going to ask you is to how is it that we avoid that? There was a point to this. I was going somewhere with this. Yeah, we're going to be looking at that over and over quite a bit. Oh yeah, I remember. Views. So views. When you normalize a database and break it up into multiple tables because you're trying to avoid redundancy and inconsistency, blah 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 blah, you create an inconvenience to the folks that are going to be consuming the data, right? Because it says, well, I want the information about all these folks, about all the students, and oh man, I need, I want the registrar's office wants the information about students, and oh man, so, some of the information for the students is over here, and the grades are over there, and the courses are over here, and the sections are over there. I have to go and retrieve some data from the sections and the courses and the grades and the students. It's very inconvenient to have to join all this information, all these records from all these different tables, right? It's just a pain in the butt, right? So views allow you to deal with this kind of issue. So is that it allows you to create virtual tables, right, that already aggregate all this information for you, right, and in a single nice convenient place, right, for maybe like a report, right, an end of quarter report, right, and where you want to look at statistics and trends and blah blah blah, right, where you aggregate a lot of data and you sum up and average and do maximums and minimums and all sorts of things into a nice consumable view without breaking the normalization of the database. Okay, so yeah, we'll spend some time in views. Store procedures and functions is what I meant. I mentioned earlier that we're going to do some programming, right? That all our queries are mostly they're declarative, right? And it has its and declarative programming has its limitations. What you can do, so we can write also programs, right, that can run inside a database to do iteration, right, do for loops, while loops, switch case, everything they would expect like a programming language, right? But instead of the data that you're manipulating, right, are rows, are tables, right? So you could do like in a loop, you can do a lot of inserts, right? If you want to create all sorts of dummy data, you can I want to insert 1,000 records. Well, you can make a loop that iterates 1,000 times and just inserts all this, or searching for some record and updating. I want to give everybody 10% salary increase, right? Well, I can write a little loop that just iterates and just looks for the particular employee and gives them all the their salary increase. Okay. All right, we created the schema. Next, we're going to create the, what time is it? 2:40. Okay, good. Let's create our very first table. And so what's in a database? What's in a, we're going to create a university, and universities have, they have students, they have faculty, they have staff, right? Well, one way to represent everybody is that, well, you're just a user, right? And then you can have different roles. The role could be a student, could be a faculty, could be a staff. Right, so our first noun, right, is going to be user. So tables, the names of the tables, the intent of a table is to describe the different things that describe whatever problem or project that you're trying to solve or represent, right? If we're trying to represent a university, well, a university is made up of people, right? They're made up of courses and sections, right? Grades and homeworks and all things like that, right? All those are nouns, right? So mostly in a table will typically, the name of a table typically will be a noun, all lowercase and plural, right? That's the naming convention we're going to follow, right? It's pretty standard in the industry, right? If you're going to have, if your table is a compound word, right? Typically, we're going to be using either dashes or underscores. No, underscores, right? To separate the nouns, right? The different words that make up the name of the table, right? Again, that's another naming convention, pretty standard in the industry. Okay, so we'll create our very first table called users, and here the nomenclature here is that there's the name of the table, and these are the properties or attributes, right, that describe that noun or that table, right? Typically, each table will have a field or property called ID, right, which uniquely identifies each record, right? Just like you might have a student ID, right, that uniquely identifies you, right, in the university's databases, right? Then we have other fields that are we call them natural fields. Natural, we mean that it represents something real in the real world, right? Whereas an ID, it doesn't really represent anything, right? It's just a made up unique identifier that doesn't really represent the real world, right? The only reason we have an ID is that, unfortunately, there's nothing unique about us, right? Our first name is not unique, right? Certainly I can find another Jose in this university. Maybe my first name and last name might make me unique, right? But it doesn't guarantee that the combination of my first name and last name make me unique. No, it's not guaranteed. Uh, it could be a social security number, but actually a social security number is another reason, right? There's nothing unique about us, and so they made up just a random number for us, right? So we are, as an identity for each one of us, we're just a collection of randomly generated numbers, right? Either it's a credit card number or a phone number or social security number, right? We're just walking collections of random numbers, and that's how we are represented in the databases of the world, right? Unfortunately, and now it depends on the context, right? If the context is within a classroom, maybe a first name and last name might make me unique, right? So within this context, maybe yes, right? I don't know, but all likelihood I will find two people that have the same first name and last name, and so you start adding new fields. Well, how about the middle name? Can that make me unique, right? And so the more fields that you add, perhaps the more unique you can be, right? That's how phone numbers, for instance, began, right? First it was just four digits, then we added 3 digits, so it's now 7 digits, and then we added the country code, right, to make it even more. So the bigger the context grew, the more fields we added to make it unique. And whenever Elon's puts his Mars colony, right, then we'll have to add not just a country code but a planet code, right? Which planet are you in, right? And so the bigger the context, the more fields you need to make it more and more unique. Or just make a random ID, and that's it. And you can get away with that. Notice the using the underscores. Notice the all lowercase. Also because SQL is case insensitive, right? SQL doesn't care if you use capital or lowercase, right? So you can mix and match. It doesn't really care. So it does not maintain the case. Okay. So we're gonna just make it a standard that it's all gonna be all lowercase, right? And an underscore between the words, compound words. All right. So let's create our very first table. And so the way we create it, we can say, we can go to table and say create table right here, or with selected schema, we can say create a new table right here. There we go. So it opens up the new table UI UI, where we can type in all the fields that describe that particular table, right? So the table will be users, I believe. Is that what we said? Users. And here's where you can type in the field names, right? So ID. Now by default, notice that on the right hand side we have all these columns describing some attributes about that field, right? Notice that PK is selected and NN is selected. PK means primary key, right? And NN means not null, right? And what that means by primary key, it means that this has to be unique, meaning the values of the different records cannot have a repeating ID, which makes sense, right? I cannot have the same student ID as you, right? It has to be unique. So our student ID or faculty ID or employee ID, those are primary keys. Yes. Also not null, meaning you have to give me a value, right? It's required, right? Meaning I will not accept a record that does not have this value for this ID. Okay. The other thing is the default. Notice the default data type, it's integer, right? So 1, 2, 3, all the whole numbers, right? Non-negative whole numbers, right? And I'm going to be lazy, and I'm going to select also AI, right? This is not artificial intelligence. It means auto increment, right? Meaning you come up with the values. Start at 1, right? And every time I put a new record, just make it the next 2, 3, 4, 5 automatically. Okay. Now, depending on the implementation, folks might have chosen instead varchar or dates or different data types. Notice that you have a lot of data types there. See that? Some folks might have chosen a varchar, characters, strings. Okay. For instance, perhaps the student ID because it has dashes in them, right, is actually represented as strings. We don't know. I don't really know what the schema for the tables where we are represented, but I know that some of us start with 0, right, and that would not be a valid integer, right? That starts with 0. So I'm guessing, and it has dashes, so I'm guessing they're using strings to represent our unique identifiers, right? I'll be lazy and I'll just use integers. So I have ID. The next one is first name, I think. Oops. First name. So first name definitely is varchar. So notice that varchar means characters. So any character, alphanumeric character, and the parentheses says how big do you want it? How many characters should I make space for? So I'm going to go with 45. Yeah, I think it's long enough for a first name, and we'll go with last name as well. There we go. And then we can just say create, apply. So notice that, again, the UI is just a convenient way of actually typing for me the command. I could have typed this myself, right? And if I was using the MySQL client, right, which is just a command line, I would have had to type this literally myself, right? The UI is just a convenience way for me to type it. So it's, the command is create table, the database, dot the users. Notice that the ID. Notice the ID is is declaring the data type, saying that it's not null, meaning it's required. It's also auto increment, so it'll start at 1, 2, and so on and so forth. First name is varchar is null, meaning that it can be null. Null meaning I don't know what the value is, right? It's okay for this to be empty. People can leave out their first name and last name. And it's declaring the ID as the primary key. Primary key, we call these constraints, right? Being an int is a constraint on this field, meaning I will only accept values 1, 2, 3, whole numbers. Yes. I'm sorry. No, you can have multiple primary keys. Yep, you can declare the combination. I'm sorry, say again. Yep. Yeah, exactly. So you can make some changes here if you want to add it. I forgot. Oh, I should have put an email in there. You can type right here. Yep. Yeah. So we call these constraints, right? Meaning the things that we will accept, right? For the ID field, it has to be a whole number, right? It cannot repeat, right? It can't be blank, right? I will set it for you. This can be all the alphanumeric numbers. I'm saying the ID has to be a primary. Not only does it have to be unique, but it can also participate in relationships with other records, right? Meaning me as a person, I can participate in a relationship with other records in other tables, right? So for instance, I might have a course table, and one of those course tables might have a field that says author, who's the author of this course, or who's teaching this course. And the value of that field could be my ID, right? So it's saying, oh, that course, who's teaching it? The value is this ID, right? And in that sense, now those two records are related, right? That record knows about the author, right? And one of the things that we need to be able to establish that relationship is that the field that is referring to the other field is called the foreign key. And it's referring to a field that has been declared as a primary key, right? So me as a user, as a faculty, I might have an ID and I am the author of this course, right? So some course record is referring to me as being the author of this course, or whoever's teaching this, right? So primary key is also preparing this to be able to participate in relationships with other records. Okay. All right. And we'll get to that later. So apply. Okay, we're done. Okay, so now notice that now we have the users table and we have the columns in there. See that? ID, first name, and last name. Perfect. We can close this. Okay. All right, excellent. So the next thing we might want to do is put some data in here, right? Insert some data. So we can do users. We can say select rows, right? Select rows, meaning what data do you have? Well, there's no data in there. I never put anything in there. And indeed, notice that here, this grid at the bottom shows the current data in the table, right? In a grid layout, right? You have the columns, and then you would have the rows down here. And notice that it's empty. We have never entered anything in there. Notice at the top is the command that we use to retrieve the data. And the command is select star from dbdesign.users, meaning select everything from the schema called dbdesign that contains a table called users, right? It went out, the database went and looked for the table, looked for any records, no rows. It came back saying, sorry, I don't have anything, right? It came back empty, and the UI is displaying as empty. Now we can insert data right here by interacting directly with the UI, or again, we can type it, right? First, let's do it using the UI. So we can type, I'm gonna leave it blank, the ID, because I remember that we made it auto increment. So it's okay for me to leave it blank, right? The database will choose for me the next valid ID, right? It'll start off with 1, and then 2, and then 3, and so forth. All right, so who are we inserting? Okay, Alice, and Bob. Okay, so here's Alice, Wonderland, and Bob Hope. Okay, remember to do enter, otherwise it'll not take that value. Once we've done that, it's not yet in the database. Right now, it's still just in UI, right? We need to say apply. And again, this is the command that is going to go out to the server, right? We're sending these insert commands, right? We're saying insert into the table call users in the schema DB design. These are the fields, and these are the values for each one of the fields. And there's two there's 2 records that I want to insert. Okay, notice that I'm leaving out the ID, right? I'm leaving out the ID, and it's okay. I'm not saying that I want it to be blank. It's because I set it to an auto increment. It'll be automatically set. Okay, so let's do the apply. Say finish. And notice that the information is there again. If I refresh, okay, notice that up here, right, the commands here, this lightning bolt means execute all my script, right? This select star, right? And then the result is displayed below in the result grid. Everybody okay? All right. And notice the IDs were set. See that? 1 and 2 using auto increment. Perfect. Yeah, so to retrieve the records, that's the command that we use, right? Select star from users. Retrieving records by criteria. Perhaps I don't want all the records. Maybe I just want a particular record that meets a specific criteria. I could say, let me copy this. Right, where you're going to, and so this, if we read this, it says select star from users, where users dot first name equals Alice. Right. Notice one thing, right? Select star from users, that we sort of know what that's going to do, right? It says meaning you using the users table, retrieve for me all the records, right? Everything. Star means everything, right? All the fields. Okay. Notice that we're not putting the DB design in front of it. See that? And the reason that's going to work is because I double clicked on DB underscore design. That is my default database, right? So any command, it's going to assume that it's against that schema, right? If I had not double clicked it, then it would complain saying, which schema? You need to tell me the schema. Yes? Okay. The other one is, notice that down below we have a where clause, which we didn't have before, right? A where clause is kind of like a filter. You know, so the select star from users retrieves all the records, which are 2. The one below filters them. It says, I don't want all the records. I only want the ones that meet this criteria. And the criteria is that looking at the table's users, the field first name, only the ones where it's equal to Alice, right? And there's only one record that does that. Now I have 2 commands. This one retrieves all of them, whereas this one is going to retrieve just 1, right? you can choose which one to execute by highlighting the command and typing the bolt, lightning bolt. Did I misspell it? I'm sorry? Thank you. I meant to do that. There we go. So Alice comes back, right? There it is. So yeah, so you can highlight a specific command and then just run that. If you don't highlight, it'll execute the whole thing, right? And maybe that's what you want. Maybe you do want to execute all of them. So what we're writing on the right-hand side is a script, okay? And for your assignment, all those commands that we've been looking at, right, where we create the table, where we insert all the information in that table, the assignment asks you to copy those commands, right, and put them in a file, give the file a specific name, right, and that's what you're going to be submitting for the assignment, right? I think at the bottom it says select all users, which is select star from SQL, from users, right? Select the users by first name, which is the one we just did, right? Okay. Select users by ID and DB design users, right? And so you can either type them all in this one screen, or you can create a brand new screen, SQL. See that? Where the commands could go in separate files. So you can create different files, right, where you have these commands, right? So this one, then you can save this, right? This would be, select, what was it? What do I call it? Select, right? And then I can save that. Yes, and that's the selecting the users by first name. Okay. Then I can create a new one, SQL, right? And then I can create another command in here. It asks, what was it asks? Oh, by ID. I want the users whose ID is number 2, which is presumably Bob. Put that in. Let's run this. And there it is, Bob, because the ID is 2, right? And so it returns just Bob. And finally, and then you can save it. Save it. What was it? Yeah, save it in a file called select users by ID. There it is. Save it. And then finally, I think it asks you that you can export the whole database, right? You right, if you want to share with somebody, right, and want to and so that I can then import the database so I can see exactly what your database looks like, right? And this is very useful for the TAs when they're going to grade you, right? They're going to look at it, says, oh yeah, you have the database, you have all the data, we're good, right? And they can run some queries and validate that all the data is there and it matches what it's supposed to do. So to export, you can go to a server, export, and it'll go with the schema that you've selected. Oh, I'm sorry, no, here. You select the schema you want to download, DB design, and right now we only have one table, the users table, and if you want to include the store procedures, any programming that you've done, or any views or triggers, you can also select the views, and then where is save? Export. Oh, dump the folder. Okay, there's the folder that we're going to dump it to. Start export. There it is. So notice that it chooses that this is the default place where it's going to dump it. See that? Under my home directory, Janunzi, documents, dumps, and then and this is the date, right? Where that's going to create a brand new folder, and in that folder is going to create a file for every table, right? So it'll create one file for users. I think it'll call like users.sql, right? So if you have 3 tables, it'll create 3 files, and each file will contain enough information to recreate your table, right? So any data that you might have had in there, right? To recreate it, you get what it's going to do is going to create a whole bunch of inserts, so that when I import it, right? It's going to create the brand new table from scratch, and it's going to reinsert all, Alice and Bob into my tables, my brand new tables, right? So that I will have a copy, exact copy of what you had. Make sense? All right. So we'll put it in dumps 2021-09-10. So start it, export. All right. So if we go there now, export. Documents, dumps, there it is. There it is. So dbdesign.sql. Right. If I open it up in NopeSA, right, it has a whole bunch of comments that don't mean anything. Notice that it starts off by, if there was a users table, throw it away because I'm about to recreate it brand new. Okay, it creates the table from scratch, just like what you use to create the users table, right? And then down below, it reinserts Alice, and somewhere else reinserts Bob. Where's Bob? Oh, there it is. Yeah, inserts Alice and inserts Bob. Right, so this basically recreates the database for me. So obviously it's going to be great for the TAs, right? That they're going to be able to see exactly what you had in your local database. You upload it for them. They'll import your database, and they will grade you. Make sense? Right. That's the plan. And so that's the first assignment. We almost did it all the way here. Let's see. All right. Any questions so far? Yes. Yes. Everybody's going to do the same thing. Yeah. For the assignments, ideally, everybody will do the same thing, right? For the projects, each one will have. We'll get to choose whatever they want to build, right? But for this, ideally, yeah. Oh, most of the assignments are going to have two parts, right? The first part is where we're going to handhold you, right? We're going to say, do this, right? And then there's going to be a second part where you say, well, now you try it. Okay, so it'll be, okay, let me, watch me do it, and then now you try it, right? And it'll be a slight variation of what it is that we just did, right? Where we show you to doing it, step by step, and then you try to and accomplish the problem on your own. We'll give you a description of what we want you to do. We won't actually do it for you. You're responsible for doing it yourself, right? There are going to be some optional parts that are fairly challenging, right? That you're not required. You're free to try them out, but they're meant for the graduate folks, right? That it's significantly more complex and asks them a whole bunch of other things that we might not cover in this class, but we do cover in the graduate class. But if you want to explore and play around with it, feel free to do that. There is no optional part for this first assignment, since it's like a half week, right? So we're asking you make sure that everybody's going to have a database running by next week. That's basically what we want. Make sense? All right. All right. Let's leave it here. All right. Yeah. So remember, every Tuesday and Friday, I'm going to have running office hours at 3:30 after class. It'll just give me time to get to my office. Not today. I need to run today. All right. Awesome. Thank you.